All right, so this is our second experiment in the second unit for grade 9 advanced science. In this experiment, we're going to be determining the boiling point of a liquid, and the liquid we're using is an alcohol. We're using an alcohol called methanol. Methanol is a highly toxic alcohol. Of all the alcohols that people would drink, they're drinking something called ethanol. Ethanol is less toxic. Methanol is actually highly toxic. You don't want to ingest this. Like all alcohols, it's also highly flammable, which makes it dangerous to use in a boiling point experiment. And as you'll see, we're going to take some steps to minimize the risk. The GHS label for methanol has indications of precautions to avoid accidents and what to do if you do get some on your skin or in your eyes. It can actually absorb through skin, so if you had a large quantity of it spilled on your skin, you want to wash that off quickly. Like any chemical, you also want to be wearing safety goggles when handling it as well. I mentioned it's poisonous, it's toxic, so you definitely don't want to ingest it. And so you wouldn't be surprised to see the pictograms with the skull and crossbones flammability because it's an alcohol, and it can actually have effects all through the body as well. So that's the liquid we're using. It's quite hazardous, but we're going to handle it safely. So first of all, I've got a setup here like you would use if you were doing this experiment yourself. In an earlier video, we saw the pegboard. You can see that I've got a Bunsen burner, a small burner underneath the wire stand. I've got this time a larger clamp attached to the pegboard, and in the clamp, first time we're seeing this in grade 9 advanced science, a flask, or more specifically, an Erlenmeyer flask. You can just refer to it as a flask. This one is a 125 milliliter flask. So make sure you can tell the difference between a flask and a beaker. The graduations on the flask are like graduations on a beaker. They're only approximate volumes, so you would never use this to measure things accurately. Now I've got the flask clamped above my wire stand with about 2, 3, 4 centimeters space there because I don't want to heat the flask with the alcohol in it quickly. If we heat it quickly, the temperature will rise quickly and we won't get very much data. So I want to heat it slowly, which is why I've got that gap. I'm going to use a bit of a lower flame as well to try to heat it slowly. Having said that, it's still going to heat up much faster than the naphthalene cooled in an earlier experiment. So we're going to want to record the temperatures every 15 or even every 10 seconds. You can decide whether you want to record every 10 seconds or every 15 seconds in order to get a good amount of data. Now I'm going to take my flask off of the pegboard and I'm going to pour into it some methanol. I've got a beaker here with the methanol already added. I'm using approximately 40 milliliters of methanol. Completely pour it in. Now this has alcohol, the beaker, so I'm going to put it well away from my setup so there's no risk of fire. I've also got the bottle of methanol here. Let me move it away, well out of way, and the lid is on tightly so there's no risk of a fire. Now when you heat a liquid in a flask, it can actually heat up quite quickly and start to boil very, very energetically. It could even boil over sometimes. So what we want to do is prevent that. It's called superheating. We want to prevent it by adding something called boiling chips. Boiling chips are little pieces of calcium carbonate, basically little bits of marble that are broken up like that. Right? They're little white pieces. I'm going to add 2 or 3 or 4 boiling chips to the flask with the alcohol in it. Keep that in mind. It's a safety feature to prevent superheating of the liquid. Next, I'll put the flask in the clamp to hold it. Now, if I were to start heating this, can you imagine what kind of safety concern would arise? We know that the alcohol is highly flammable, while its vapor is even more flammable. So if I were to heat this open container with the alcohol vapor is going to come out of that flask and would almost certainly catch fire, and we'd have a very large fire here. That would be dangerous. When you do this experiment yourself, you take a rubber stopper that has 2 holes in it. One of the holes has got the thermometer pushed through. The other one has some glass tubing that's been bent with a rubber tubing attached. Now, that will always be set up for you in our lab. One of the most common accidents in the science lab is when a student or a teacher even tries to push something like a thermometer or glass tubing into a rubber stopper. When you push, it may break, and then you cut your hand, sometimes quite severely. So we always use appropriate lubrication, like an oily, we use glycerin to make it easier to push the thermometer and glass tubing in. You can very carefully adjust things if you have to, but you would never be pushing this in yourself. You'd ask a teacher or the lab assistant to do that for you. Now, when you do the experiment yourself, you would push the rubber stopper into your flask and give it a twist to make a tight seal. It doesn't go all the way into the flask. In fact, this stopper is a little tiny bit too small for that flask, but that'll work. Now, what's the purpose of this rubber hose? Remember, as we heat the alcohol, the vapor will rise, and that vapor is highly flammable. So this hose is going to take the vapor out of there and send it away. Now, we don't want that vapor to be coming out of the hose and perhaps catching fire, so we have a beaker of cold water. Then inside that beaker, we have a test tube, an empty test tube. I'm going to be placing the rubber hose all the way into the mouth of the test tube like that. And I'm going to place that entire setup, the beaker of cold water with the rubber hose in it, far away from my beaker, far away rather from my burner. You might even place this behind your pegboard so that it's pointing away from the burner. You want the mouth of the test tube pointing away from the burner as well. So having this cold water bath to collect the alcohol vapor, when the vapor goes into that test tube and then cools down in the cold water bath, it will convert back to a liquid alcohol, which is less flammable than the vapor. So that's a safety feature so that we don't have the very flammable vapor coming out into the air. For this to work, you need the beaker to be about 2/3 to 3/4 full of cold water. You need the hose almost all the way to the bottom of the test tube, and you'd like that all to be as far from the burner as you can practically do with the length of the hose we have. Now that's ready to go. You would take your burner out from underneath, you'd light your burner, then you'd watch the clock. When you're ready to start timing, in fact, you could take your initial temperature at room temperature, then that would be at time 0, and then very quickly you'd put the burner underneath the stand, and every 10 to 15 seconds you would record the temperature as it rises. Eventually the alcohol is going to start boiling and you would collect the data, but you would stop and before the liquid fully evaporates. Always stop before the liquid fully evaporates. Otherwise, the temperature inside there would suddenly rise very dramatically and the thermometer would break. Also, heating an empty flask, the temperature would rise so quickly that the flask could also crack. So you stop heating, turning your burner off before the flask gets empty, or you would stop collecting data if you have enough data to create a good scatter plot, a good graph. Now, today, I'm going to be using a slightly different setup. Instead of the normal thermometer, I've got a temperature sensor. I'm connected to a LabQuest interface, which is displaying the temperature here on the iPad. And I've got a glass tubing and rubber hose, which will send the alcohol vapor to my test tube to condense safely. All right, so the hose is near the bottom of the test tube. I've got my setup. The stopper is in with a nice little twist, so it's a tight seal. I've checked my flask. It has no cracks on it. Having said that, anything could happen. The flask could break. This experiment does require you to be careful and cautious. Having said that, every year grade 9 students do this experiment successfully. It's an experiment that's going to go quickly. It's not something where you have to be really afraid. You just have to be cautious, okay? All right, so I'm going to start. I'm going to light my burner. When I light it, you can record the initial temperature you see on the screen. In fact, you could do that right now. That would be your temperature at time 0. I'm going to place the burner under the flask, and when I do that, the temperature will start rising. You're going to collect the temperature data every 10 to 15 seconds, but choose a time, either every 10 seconds or every 15 seconds, and I'll let you know when we're going to stop collecting data. So here we go. All right, so I'm going to now light my burner, turn the gas on, bring my match to the mouth of the burner. All right, I've got my flask again about 4 or 5 centimeters above that wire stand, but still I want to slightly lower the flame. I'm going to adjust the gas to get a slightly lower flame, and we're ready to start. So I'm going to put the burner underneath. Now you may tell from the temperature on the screen, this is trial 2. I had to adjust the wire stand, so our initial temperature is a little higher than it was earlier. That's okay. You can record this as your initial temperature times 0, and when I put the burner under the flask to heat, every 10 seconds or every 15 seconds, you record the temperature on that screen. Now, let me just point one last thing out. The temperature sensor doesn't make quite the same seal with the rubber stopper. It's possible during the experiment that a small flame will appear here. I don't think that's going to happen because I've taken some measures to prevent it. But if it does, I'm just going to blow that flame out and we'll just continue. So here we go. All right, every 10 or 15 seconds, you should be recording a temperature value. Now that I've got the burner going, I don't want to adjust it, otherwise that will change the rate of heating and your graph will change its shape. Okay. Personally, I would be recording the data about every 10 seconds, but that's up to you. All right, so the temperature's risen quite quickly. All right, and then you notice that the temperature seems to have stopped rising on the screen. Okay, there's some wisps of alcohol vapor coming out of the tube where it's condensing, but it's going away from my burner. I think we're good. So we're going to collect data every 10 seconds or every 15 seconds. It's boiling quite vigorously in the flask. We'll let this continue to collect data for about another 2 or 3 data points. This is a very quick experiment. As the vapor goes into this tube, it is condensing back to liquid. You can hear the bubbling liquid in that test tube. All right, so you are recording temperatures every 10 or every 15 seconds. And that should be pretty good. All right, so we should have enough data. We're not going to let the flask go anywhere near dryness. We just want to, in this case, we can stop because I used quite a bit of alcohol in the flask. We can stop well before it goes dry. All right, so there you have it. I'm going to stop heating. So the gas has been turned off, the burner's off, there's no flame at this point, no risk of fire. The hose is quite hot because that vapor was hot. I'm going to pull it out of the test tube, shake it off to get rid of any alcohol that's on the end, and I'm going to put that off to the side of the cold water bath. And if I look inside that test tube, you can see there's quite a bit of alcohol here. So think about what happened. The alcohol in the flask boiled. As it boiled, it turned from a liquid to a vapor. That vapor traveled through the hose into this test tube, which was sitting in cold water. And now, as it sat in the cold water, it condensed back to a liquid. The cold water is now not that cold. It's actually kind of warm because of the hot vapor that was coming into there. All right, so you have enough data now. You're going to make a temperature time graph. So temperature on your y-axis and time on your x-axis, and you'll make a graph, and we'll analyze the shape of the graph to determine the boiling point of the methanol alcohol.